Hello everyone, Happy New Year, and I'm so sorry that I've been away for a while. I've been in NYLC orientation camp. I'm going to link a post to everything I wrote about that, so we won't dwell too much on that in this video. But basically, I've been gone for nearly 2 months without access to my laptops and recording gadgets. So we're starting a new year, and I decided to introduce a new playlist series thing to this channel where we talk about books, we review books, and it's going to be a review of technical books. So technical books, I know you know, but just to get out that nitty gritty, they refer to comprehensive material that provides information on specialized technical subjects, right? Think textbooks in school or any programming books. For us, they would be programming books like, well, you can already tell from the title of this video, but tada, Eloquent JavaScript. In this series playlist book club, we will be starting out with Eloquent JavaScript. It's a book that helps us go in depth into the nitty gritty of what JavaScript is. And this book, why I specifically chose this book, because it covers a whole lot of important aspects from the basic structure of JavaScript, the control flows, data types, values, to the DOM, to functions, function expressions, and even JavaScript in the server side. And we work on a lot of projects. You know, this book is specifically good because we also work on projects in this book. There are a lot of hands-on projects to work on, right? There's robots programming, there is websites. We're going to see all of that, right? But this book goes in depth and it's easy to understand, kind of. It is easy to understand. I've read it about 2 times. I never finished it in depthly. I always skimmed through the first time, and then the second time I got a lot further. And then I realized that while technical books are so good, they can be sometimes hard to stick to, be consistent with. And that is the aim of this book club series, that together we are able to study these books and hold ourselves accountable to actually finishing them. Books are such hidden gems, like they are comprehensive. Books take a longer time to write. There's research, there's editors, there's so much going on when it comes to writing a book. And while I think that programming languages involve, books themselves don't get outdated. They do not, because it's just like English and French, right? In both languages are different, but we have a common foundation. We greet. In English, we greet good morning, hello. In French, it's bonjour, ça va. Now, the syntaxes, how we say these greetings are different, but we still greet. We have a means of communicating that greeting. So I believe that regardless of when you read a book, regardless of how long it has been written, it will always be relevant. But this was not written so long ago, but it's still very relevant. There are still concepts that hold true to today. So yeah, that is what we'll be reviewing in this book. And also, this summary is not a way to stop you or to act as a replacement to actually reading the book. We will be doing summaries and then working on the exercises and building the project in the book. But as much as you can, if you can, do read the book for yourself, because again, there is nothing, it's nothing compared to actually reading the book for yourself and putting your own concentration on it. Now that we've done, seen what we want to do with this series, why read technical books? Why does this book club even exist? And I've even touched a bit on it, but I'm just going to go over it again. The extensive research put into books makes them a reliable source of truth. Like I said, a book is not just written in a day. A good book anyway. No book, rarely and ever any book is written in just one day, edited in that same day, proofread in that same day, and then published in that same day. It's just not possible. It doesn't even just take weeks. This project takes months, they take years. Books require extensive thought to be put in them. And because of how technical books are written, because of the technicality of a technical book, if you are writing a technical book, that means that you have sufficient knowledge on that subject. You cannot write what you do not understand. It is difficult enough explaining it. Now talk about writing it. Therefore, the amount of research, effort, intentionality put into writing books makes them a reliable source of truth. If you see any book, there was a book I read on data structures and algorithms that introduced me, because I'd read a lot, but it was just so hard to comprehend. And then I finally found the one. I'm going to show it somewhere, and I'm also going to link it. And that book made me understand data structures and algorithms. It broke it down. It was so comprehensive. After that, it was like I received a light bulb on a subject I'd struggled a lot with. And this book is so old. Node.js was not a thing when this book was written. Const-lets were not things when this book were written. Class was not a thing when this book was written. That book still uses function prototypes, and so many concepts that are introduced in JavaScript now were foreign in that book. Foreign in the sense that they were not even used at all. We're declaring var, and the author was trying to explain to us that, var has scope and all of these things. But these issues have been fixed with const and let. But that's how old that book is. But that book was still very reliable, because while syntaxes in JavaScript evolved, syntaxes will always change, syntaxes will be improved, the fundamental truth of what that syntax is based upon cannot change. Var, const, let are all a source of holding a variable, right? It's a way of holding a variable. We would always have something to hold a variable with. Even if tomorrow we don't use const and let anymore, there will still be something else to hold a variable. So that is the point. Books don't get outdated. And then you learn to read other people's code. Because if you are reading a technical book, a programming book, best be sure that there's tons of code in that book. And there's tons of code in Eloquent JavaScript, which we'll be reviewing. And one of the ways to grow as a developer is to read other people's code and try to understand what each line of code is doing. This function is called, where is it coming from? Where is this object being used? Why is it being used? Why does this exist? Why is this being used? So reading other people's code is a way to get better as a developer, and reading technical books help you do that. Also, the sheer amount of intensity used in reading helps improve your concentration as a developer. And trust me, concentration and deep work is something that we developers definitely need. Now, this is just an introduction of the book. We'll jump into the chapters, first chapter and everything, and start getting technical. But in this introduction, we just have a quick overview of what the book is meant to do and what the book aims to do. In this book, the author talks about programming, what programming is. Then, of course, if there's programming, then what are the languages to program with? Talked about the evolution of programming languages. Then we got introduced to JavaScript. We got introduced to code, what code is, because code is not exactly the same thing as a program. Then we got an overview of this book, what you can expect to learn. Then some thoughts on programming designs. This was not a subtopic in that introduction, but it was something that he touched upon. He made a comment on it, and I just loved that comment so much. I was like, I have to share this in the review, definitely. And then finally, closing thoughts. Spoiler, coding is hard. So let's jump right into it. Programming. So this book is about instructing computers. That is what we're going to be learning. If you are, whatever level you are, right, I think that this book is going to take you to the next level. Like if you're a senior, the next level. If you're a mid-senior, the next level. If you're mid-level, right? So this book is about instructing computers. That's basic. You know this. I hope you do. And if you don't, that's fine. That is where programming comes in, because we want to instruct our computers what to do. Programming is the act of constructing a program, because we are basically telling our computer that, okay, I want to do something new. You don't just want to open emails. There's already an application to open emails. But what if you want to build something completely novel? You want to develop a software. Developing a software is telling a computer what to do. telling a computer what to do is programming. Next, we have the programming language, because if you want to tell a computer what to do, the computer has to understand what you are saying. We human beings, we have our languages. I'm currently speaking in English, which you understand. But other people, yeah, I'm currently speaking English, there are other languages, and computers don't quite speak our language. Even though we write all of this code in English languages or whatever language, I mean, they are Ruby, they are Python, they are JavaScript, but it's still understandable to us as English. Computers don't understand that at all. They speak in ones and zeros. They speak in electric current on and off, right? But we don't speak that language. It would be tedious for us to try to think in ones and zeros. It would be difficult. Have you ever seen or done or tried to learn Morse code? It is difficult because it is not our makeup. We are so used to words that we can easily understand. And that leads to the evolution of programming languages. So computers understand zeros and ones. And earlier on, when computers were created, that is how the early computer scientists actually spoke to computers. They would they would punch buttons, they would connect electric circuits, they would use the AND gate, the NAND gate, they would combine all these things to actually talk to the computer. And then later on, we started getting languages like BASIC, like Fortran, where you can just write programming languages in a way that is somehow understandable to both human beings. And then there is the compilers and interpreters that translate these languages to ones and zeros to the computers. And now we have the JavaScript, where you can just easily write syntaxes that make things so much easier. So programming languages are the languages with which we used to talk to computers. Computers speak in 1 and 0. That was the way it started. But now we can write our own language, a common syntax, and then have interpreters and compilers translate our English-like programming languages to ones and zeros that our computers understand. Now, what is JavaScript? I know you already know what JavaScript is. If you are here, then you definitely know what JavaScript is. But JavaScript is a programming language. It is used to tell the computer what to do. It is used on the web. What else do I know off the top of my head about JavaScript? Or let's just look at the slides, right? It was created in 10 days by Brendan Each. If you've ever learned JavaScript in a formal environment, let's say bootcamp, this was drilled into your head. You know it was created in 10 days by Brendan Each. And even people who don't use JavaScript use that as a score point to talk about the frailty of the language that wasn't well thought out because it was built in 10 days. But that is subjective. Then it was introduced in 1995 as a way to add programs to web pages in Netscape Navigator browser. So the browser at the time was Netscape Navigator. The creators wanted it to be more interactive, and so the language came about to add programs to the web browser. It has nothing to do with Java. Again, this is such popular knowledge. JavaScript has nothing to do with Java. JavaScript is to Java what carpet is to car. Unrelated. Yeah, Java was a popular language at the time, and the marketers wanted it to ride off the popularity of Java. So they thought, let's just name it JavaScript. After major browsers started to adopt JavaScript, a standard document was written to describe the way the language should work uniformly. This standard is the ECMAScript standard, and it is also used to call JavaScript. You can call JavaScript or ECMAScript. Either of these works, and you see it out in the wild as ES6, ES7, ES8. It's still JavaScript. So now that more web browsers, more than Netscape Navigator browser, now use JavaScript, there has to be a way to agree that JavaScript has a uniform standard. Though, if you go to different web browsers right now, you would see that some of them have different behaviors. There are some programs, right, that will not exactly work on different browsers. So sometimes when you want to write a code in JavaScript, you still have to check the MDN docs to see if it is compatible with a certain browser. That was one of the issues with Explorer. It adopted JavaScript updates a little bit late, and so developers quickly shunned that browser out. So now other major browsers that use JavaScript, there is a standard they have to follow. If JavaScript should introduce a new DOM element, all of them have to use it, and none of them can decide to just create a new DOM element that is not applicable to that is outside of what's the standard, right? Because then other browsers don't have access to it, and that kind of like disrupts the ecosystem. So ECMA standard is the standard that determines that all of the browsers that use JavaScript have a uniform standard at the very least. Now, JavaScript is also being used on the server side and the database. Like earlier stated, JavaScript was created for the web, for the browsers, to add interactivity, to add programs to web pages. But now it's also being used on the server side and is being used in databases like MongoDB, server side, Node.js. Now, what is code and what to do with it? I did mention, or the author did mention, that code is different from programs, and code is the text that make up a program. So let's say I want a program to tell a robot what to do. The code that I'm writing a particular instruction is just a code. The entire program is made up of code. So you can think of code as a subset of program. And yeah, let's say I want to build a calculator, right? A calculator has so many things: addition, subtraction, factorial, modulo. There are so many things that a calculator can do, right? And now I've extracted a piece of code that finds the factorial. Now that is a code, but the entire piece of that calculator is a program. So that is one way to think of it. Now let's look at the overview of the book, what you can expect from this book going on forward. The first thing is that there are about 21 chapters. 12 chapters is based on basic JavaScript concept. 7 chapters talks about JavaScript in the web browsers. That's the behavior with the DOM. 2 chapters talk about JavaScript in the Node.js environment or the server-side environment. We also have 5 projects to work on. There are exercises in every chapter, but there are 5 major projects: a delivery robot, programming language. You will build a programming language, a platform game, pixel paint program, and a dynamic website. Now, these projects, right, I think that they are good projects to add on your portfolio, on your resume. They look good. But beyond looking good, they're also quite technical. They are a good way to learn the basics, the foundations of JavaScript. Like I said, I've gone through this book mostly. They are such a good way to solidify everything you think or know about JavaScript. Everything right now, if you're a front-end developer or a back-end developer working with JavaScript, a full-stack developer, server-side, client-side, using frameworks, these JavaScript frameworks are built on JavaScript. Now, a common mistake is people just jumping into the frameworks, jumping into JavaScript library without solidifying the knowledge of JavaScript. Once you properly understand JavaScript with this project, jumping into any kind of framework would not be tedious at all, because again, there are JavaScript libraries and frameworks built on JavaScript. Also, we have topics to explore. We have the control structure, the for loop, the while loop, functions, function expression, arrow functions, other functions. We have error handling, there's bug fixing, regular expressions, modularity, async programming, communicating over the network with HTTP, the DOM, which is Document Object Model, and JavaScript in the server-side environment. That is JavaScript in the Node.js environment. Now, best practices. Again, this was something that was not exactly an excerpt, like a major subtopic in the book, but I read it and it just clicked, right? So I'm just going to read it out to you. A program is a building of thoughts. I want to do something crazy. I'm going to write a program to build out my thoughts. It is costless to build if you know what you are doing. If you don't, you employ other developers, in which case it is costful. But if you are coding yourself, it is costless to build. It is weightless mostly. You're just coding on your laptop, and most laptops aren't heavy nowadays. And it grows easily under a typing hand. A code that started out with Prince Hello World can easily turn into thousands of lines. Now follow me. But without care, a program size and complexity will grow out of control. This is true. confusing even the person who created it. Keeping programs under control is the main problem of programming. This is when you start working with larger code bases. When a program works, it is beautiful. The art of programming is the skill of controlling complexity. The great program is subdued, made simple in its complexity. Now, follow me. I don't know why I highlighted everything since everything made sense to me. But it's just talking about how we write, what programs are, and how easily programs can grow from a simple hello world to something really large and impressive and complex. If you're already writing code for a while, you know this to be true. If you're just starting out, your 200 line of codes is quickly going to become 2000 before you know it, and then you'll come back to it 2 weeks later or 2 months later and you are so confused. You are wondering, who wrote this? I don't understand what's going on here. It happens all the time. Now, it now goes on to say that some programmers believe that this complexity is best managed by using only a small set of well understood techniques in their program. They have composed strict rules, best practices in code, prescribing the form programs should have and carefully stay within their safe little zone. This is not only boring, it is ineffective. New problems often require new solutions. The field of programming is young and still developing rapidly, and it is varied enough to have room for widely different approaches. There are many terrible mistakes to make in program design, and you should go ahead and make them so you understand them. A sense of what a good program looks like is developed in practice, not learned from a set of rules. That I should have highlighted. A sense of what a good program looks like is developed in practice, not learned from a list of rules. Now it's just saying that programming becomes complex, right? I mean, you can't compare the program to writing a simple to-do list to the program that powers Uber. It's not possible, right? You know that code is massive and they probably adopted a microservice structure of writing code. But the point is when starting out, right? Because everyone has best practices and best unique and best techniques. If you go on the internet now, best practices when writing JavaScript code, best practices when writing React code, best practices when writing Vue code, best practices when writing Express code. There are best practices all over the place. And best practices are made up by people who encounter the solution. For instance, Airbnb have their own best practices when they call it ESLint. And that was after the engineers have probably ran into some issues. Let's say someone was using a certain styling choice, someone else was using a certain styling choice. It was causing conflict, and they're like, oh, this should be our unified styling, right? It was solving their problem. But the problem nowadays is everyone is adopting these standardized best practices without first writing their own code and then deciding the best design practice for their own code. Now, of course, when people have done the work to come up with best practice, it is only wise that you save yourself some time and not do trial and error by trying to come up with something new. They've done the heavy lifting for you. They are brilliant engineers, right? True. But if you are starting out, now this is something I see when people are just starting out, you are working on a personal code, personal project, and you're worrying about all of the best practices, is going to get in the way of actually doing, because then you are already thinking about modularity, structure, and all of these things that get in the way of actual critical thinking. This is subjective. This is up for, it is not final. It's just, I read it and it was a light bulb moment in my head. You can choose to interpret it however you want, but I'm choosing to interpret it that when you are just starting out or working on a personal project, don't worry too much about best practices. Just build, make something. I know they say refactoring is a lie. Nobody ever goes back to refactor. But if it grows and you need to do something, let's say, for instance, your data is being exposed and you know that you need to protect that data. Now you are, something you built for fun now has 200 customers and their data needs to be protected. Then it just makes so much sense that you learn about modularity to abstract the user's data from what every other person can see. But the point of trying to abstract when you've not even had any user at all, a personal project, is called over engineering. So yeah, best practices are good, but I see them being marketed a lot. about if you are a junior trying to work on a personal project, just build something worthwhile. Don't stress yourself too much. A sense of what a good program looks like is developed in practice, not learned from a set of rules. But it's a personal project. Break rules and learn from them. Bugs are your best friend. They teach you what you shouldn't do next time. So don't be afraid of bugs. I just wanted to share that because, man, I love that so much. Closing thoughts, and this is something else that I loved and you are going to need. There will be times when reading this book feels terribly frustrating. I am prepared for that. I hope I am. I am prepared for that. I hope you are too. If you are new to programming, there will be a lot of new material to digest. Much of these materials will then be combined in ways that require you to make additional connections. Beyond the book, there will be a lot of googling, researching. Don't confine yourself to this book. If you need to make external researches, please do. It is up to you to make the necessary effort. When you are struggling to follow the book, do not jump into any conclusions about your own capabilities. It is not about you. You are not slow. You are not less smart. You don't belittle yourself, basically. As long as you are putting in the necessary effort. If you struggle is fine. Struggle is a good sign. It means you are stretching yourself. You are fine. Just keep at it. Take a break, reread some materials. Make sure you read and understand the example programs and exercises. Make sure you attempt them yourself. Make sure you actually know what each line is doing. Learning is hard work. It's hard work. But everything you learn is yours, and it will make subsequent learning so much more easier. When action grows unprofitable, gather information. When information grows unprofitable, sleep. Your brain will work together, connect everything that is not working, or everything that you need to learn to move past a bug. So just have fun and learn. It's hard work, but you got this. See you in the next chapter.